Hello, everyone. You are welcome to today's session. And in today's session, we are going to have quite a short one, a very short one. Okay, our task here is to look at the solution to the lesson two assignment on the Earth as a sphere, global math. And the assignment is exactly what you have on your screen. So let's go and look at the solution slide. Okay, so at this point, this is the two towns C and D on the equator. So we know that these two towns, so let's as you read question, underline the salient part. You have the solution there. So I'll walk you through the solution. And because I've gone through your submissions, I will address the concern that came to bear from your solution submissions as well. So, okay, on the equator, so they share a common latitude, and that's the equator. Okay, and okay, the longitude of C is 67 degrees east, and that of what D is 123 degrees, 123 degrees east. Okay, so now illustrate the information in a diagram. Then, okay, so you have the various questions there, as and when I'll read it and we solve it together. So as usual, for reading question, underlining the salient part, what do? The first thing that you write is what? Solution. After writing solution, you pick the vital information in the question that will help you deal with what? The solution. So in this case, you'll be given 2 points. Okay, the 2 point, the first one is C. The C, you know that in terms of points on the Earth surface on the globe, we always state what? The latitude followed by what? The longitude. But the latitude of C is the equator. We know that equator is a latitude. So that would be 0 degrees. And equator has no direction. That's the baseline for the measurement, okay, to the north and to the south. So you can't say 0 degrees north, 0 degrees was south. Okay, it has no direction. So please take note of that. So it will just be 0 degrees. Then you are told its longitude, okay, 67 degrees east, and that is also stated. And D, latitude 0 degrees and longitude 123 degrees east. Okay, so the information that we have here is what we have extracted in the point, exact point form. Okay, now we come to I, where we were asked, okay, to illustrate the information, okay, on or in a diagram. Okay, so as usual, once you are going to plot based on what we did in lesson one and lesson two. Okay, so especially in lesson two, what do? You indicate your indirectly your x and y axis. In this case, your west east lines and what your north southward lines. Okay, which will be your equator and what the meridian. Okay, so take note of that. Okay, so in this case, okay, this is it. So it means your 0 degrees, okay, what do you call it? Latitude is already indicated, and that's what we have here. Okay, so for each of the points, one of the lines that we will need, our reference line already drawn, which is the equator. Then what do? We come towards the second, okay, that is the longitude. Okay, so in this case, the longitude of the first one is 67 degrees east. East to this side, so how do you draw it? It's going to be this way. That is 67. Okay, you come down, you curve it up to this point. Okay, so that is your 67 degrees east, longitude 67 degrees east. So where this 67 and the 0 meet, that is where your C is going to be located. Okay, then you come to the other one is 1, 2, 3. So the more you move away from the origin, the bigger your angle. So it means that one should be somewhere here. Okay, so in this case, this is your 1, 2, 3 degrees what? East. Okay, longitude. So where that one also meets what? This. Okay, that is where you are going to label that as D. Okay, but in actual fact, we could have done this instead of using, okay, my circle is not, so using this, okay, you know that this is just indirectly inside the sphere. So this would have been, if you wanted to draw, okay, your circle for your equator to be a circle, then this is how it should have been. So that when you draw, okay, it is this point, that will be the first one, and the second one will be what we have here. That will be the exact picture anyway. Okay, so no issues at all. But if you draw it this way already, you've indicated that this is your 0 degrees, which is the equator. So that's okay. So at this point, you have, okay, 2 points on the Earth's surface. So the diagram, the information that you have there is what you have here. So solution to I, already catered for. So in this case, we'll get our full score for the I. Now let's come to the II. We have to find the distance between C, okay, and what D along the equator. Okay, so it will be along this. Okay, if you use the lines, okay, the picture might not come out clearly. Okay, but in any case, if I explain, you will still get it. At normal circumstances, that's how it's supposed to be. Should have been. The real picture is what I'm going to. Because it's the equator, okay, when you are drawing your arc, you should start from here and end here. Okay, but it will be more or less a curve. Okay, so this is how it should have been. Okay, and the other side will be at the back. My professors, I hope you get my point.
Yes, please.
Okay, so in actual fact, okay, the D is here and the C is here. Do you get the true picture now? Okay, so that is supposed to be, but if you draw it that way, still that is okay. All right. So at this point, yeah, only that I just wanted you to know, picture the real okay situation so that you can appreciate the concept that we are dealing with better. Okay, so at this point, this is what we have. Okay, so we are looking at, so we will be looking at the arc length here, but because we didn't use this, we are looking at the arc length on the equator. So it means here the arc length that we have here is on the equator. And it seems, okay, some of you forgot that the equator, though a latitude, okay, that's a special latitude, that is what, a great circle. So some of you, okay, because you realize that it was a latitude, okay, you use what, small r for it. The radius will not be small, it will be big R because it is a great circle. The only latitude that's a great circle is the equator. So most of you use alcos. No, there shouldn't be alcos. But even if you quote it, okay, you substitute your zero, then you go back to okay factory settings. I mean your R. Only that you write more because you didn't think before writing. The formula itself, you write more before you go and substitute and come and deal with what the situation. So in this case, we know this is a circle that will come out of what a great one. So that is going to be capital R. Do you agree now, Mama Versus?
Yes, please.
Because the distance is along the equator. So you've been told once it's along the equator is a great circle. Okay, so now what we need, so we have indicated the point C and the point D. What we are left to find is the angle of difference. Then we can find this arc length because that's the distance between C and D. We're not told, okay, whether the distance is the shortest or what. So once we didn't qualify, we are talking about the arc length. So II, therefore, distance will be equal to arc length CD. So we are looking at the length of this arc CD. And the length of an arc, okay, where the arc is coming from a great circle is given by theta sub d over 360 degrees times 2 pi r, or just theta over 360 degrees times 2 pi r. But how do I get my theta? My theta is what? The angular difference. That's the difference in angle, okay, between the 2 points. And here, how do I find, I know my 2 points. How do I find my difference in angle? They share a common, okay, latitude. So I have to use the longitude to determine the difference in angle. And how do I do that? I base that on the angles that I have there, but the direction will inform me as to what to do, whether to add or subtract. So once the directions of your longitude, okay, the two longitude here for each of the points, once the directions are the same, what do? We are going to say that we will subtract one from the other. If they were in the opposite direction, they would have added. Okay, so in that case, we are supposed to get 123 degrees minus 67 degrees. Remember, always you subtract the smaller one from the bigger one, and that will give us the 56 degrees that we have here. Is my point well made, my professors? My professors, are you with me? So in this case, I know all the parameters in the formula. Okay, pi was given, r was given. My duty was to find the theta sub d or theta if you put theta here. So in this case, for me, this is my theta sub d. Okay, where is it? Okay, so this is my theta, okay, sub d. All right, okay, so I go and substitute and the rest will be calculator work. Okay, so at this point, this is what you get. And don't forget, if you are approximating, you approximate to what, 4 dp. Okay, and don't forget your unit as well. So the question was so easy. Okay, the once you untie the knot, the knot is to determine whether your R is big R or small r. That's all. Whether your circle is a great circle or a small circle, because each one and its formula that you are supposed to use. Okay, now let's come to the second, the III. How far is C from the North Pole? That's where most of you, this question there, most of you got it but wrong. I think it was only one person that gave me, okay, the solution, and I mentioned the name already. Okay, exactly what you have. So let me explain exactly what we have here. So we are looking at those of you who use the line, the picture will come out better. So we are now looking at what we said. Okay, find how far is C from the North Pole. So we are how far means we are looking at distance. So that distance that we are looking for in III, okay, will be equal to arc length. So we are looking at the C from the North Pole. This is the North Pole, and this is your C. So we are looking at this arc length. So the arc length was CN, and that's what I have here. Okay, the North Pole, I have represented it. Okay, and I know that you also represent that by N because of how you've been trained. Okay, so that will give us, we are looking at this distance. And obviously, if you look at this arc is on what? On a gray circle again. Okay, it's on a gray circle. You can see from C to D is on a gray circle. Okay, so take note of that. So in this case, if you are looking for the angle, okay, you know that the angle obviously will give us, that will be this angle. Remember I told you, how do you get your angle? You draw lines through each of the point to the origin. So from here to here, origin, from here to here. So you see that your angle there will be 90. My professors, I hope you are following. Is everyone with me? Hello, is everyone with me, my professors?
Yes, please.
Okay, so if you have any questions, you can ask. So this will be 90. So here too, when you are quoting, it will be arc length CD, and like I said, okay, the arc is on what? On a gray circle. So it will be given by the same formula. So here the only note is for you to know the angle, and the angle will be 90. So if you substitute and you simplify using your calculator, this is what you are supposed to get. And you don't forget to indicate your approximation. So please take note. So this was supposed to be the ideal solution to the assignment. Okay, Prof. Akosia.
Please, does it mean the North Pole is not a point?
No, the North Pole is a point. Okay, it's a point directly. So that's why all this is a special point, the North. Okay, C is also, so that's why I said from here to here. You can find distance between 2 points. So obviously the North Pole is a point.
And so I thought the distance was going to be a line.
The distance is going to be what?
A line from C to N, since C is the point and N is the point.
Okay, so okay, why didn't you say with this one? Is C not a point?
With
No, with the II, is C not a point?
it's a point.
Is D not a point?
It's also a point.
So why didn't you say that, okay, you will use that same idea? Remember I told you, if we want you to use that line, we will qualify it,
Um,
the shortest, and it will be a line. If you don't see that, then it means we are dealing with an arc. Please, did I or I did not? I did, right? So check if it's qualified with the shortest, then you know. That's why I asked you the shortest distance between 2 points will be what? It can never be a curve, it's always a straight line. Okay, so it means in that case you would have found, okay, the length of the chord here rather. Okay, let me see. So it would have been this chord length that you are supposed to find. Okay, not the arc length. Is that clear? And even with that one, it would have been easy for you anyway, because you know that the distance here, this will be from here to here is a great circle, so it will be big R. This will also be big R. Okay, so indirectly, because there's a right angle triangle, you can easily find that one. That one will be a pull chop if you qualify that distance from C to the North Pole. You get it?
yes, please.
Okay, very good. Okay, any other questions before we finally bring the curtains down? Okay, on this. Is the explanation okay to everyone? Please, some of you wrote stops for me. Okay, so please, if you don't understand, let me know. I've told you this question, okay, questions on global maths, okay, take note of them, most likely. So make sure you get it. And it's a bonus question because I've given you all the tools. Okay, and so those of you even quoted, okay, assuming you quoted, you could have cured that because you can still get it. Assuming, okay, you quoted your, okay, 2 pi r, okay, cos theta. Assuming that's what you quoted. Your theta, remember theta, we said it will be the angle of common latitude. But some of you, I saw someone using 67. 67 is not a latitude, it's a longitude. So the common latitude is 0. So if you come and put 0 here, you get cos 0, which is 1. So you end up getting this. So it wouldn't be costly, only that you write more. But once you quote this, we'll know that you don't appreciate the concept. Okay, you assume the line that you are dealing with, okay, or the curve that you are dealing with, a circle is a small circle, but it's not a small circle. You get, and only that here you are lucky because the angle that you have there, okay, is 90, which will still bring out the big or great circle nature of the formula. Do you get the point? So those of you who quoted this and substituted would have gotten it anyway. Okay, only that some of you didn't substitute the exact angle. The common latitude is the 0 degrees. Okay, and that is supposed to give you what you have there. Okay, so are we good to go? Cos 0 is what? Cos 90 is 1. Cos 0 is what? I was expecting you people to talk as if, please talk. I know you people are good. So please talk. Don't take anything that I tell you hook, line, and sinker. Hello, cos 0 is
Cos
what?
0 is 1.
It's 1. Okay, so you know that definitely. So once it's 1, you end up getting exactly what you have there as well. Okay, all right. So you know, we always say this cos 0, cos 0. So that one is something that even the non-math student, they know because everyday language. Okay, that is square 0. Okay, I mean, back to square 1. These are the languages that, I mean, statement that we make. Okay, even if you are not a math student. Okay, so that will be it for the solution to the assignment. Okay, thank you very much. Okay, God bless us all.